All right, let's look at the four main things we've done with carbonyls. There's a little bit of a review. Carbonyl reactions. First thing we learned about carbonyls is we can attack them or an organometallic. Carbon-based nucleophile. So here we simply attack the carbonyl. Just draw something generic. Acetone, and we'll treat it with methyl magnesium bromide. This is going to attack. There's our new methyl group. We form a tetrahedral intermediate. And then we'll need another step. You know, they have to be separate steps. You don't want your water mixing with your organometallic reagent, because organometallics are bases and they'll get deprotonated. And so we make an alcohol. That's one reaction we learned. We also learned how to do enolate alkylations. So we can take a carbonyl, again, a nice generic carbonyl. We'll just use acetone. We can treat this with LDA, and then treat, and that forms an enolate, and then treat with some sort of, specifically a primary alkyl halide. And we will alkylate this alpha carbon and put this new alkyl group on our carbonyl. We then learned the aldol reaction. That was a three-step process. I'm not going to go through this whole process because there are several videos on it. But the aldol reaction forms a beta-hydroxyketone. Again, we're relying on formation of an enolate. So we had an enolate attacks a carbonyl, typically an aldehyde. What's our fourth reaction among all these carbonyl reactions? It's the other flavor of the aldol processes. It's the aldol condensation. And in this case, we formed an alpha beta. Whoops. Can I do that? Perfect. Alpha beta unsaturated ketone. And much like the aldol reaction, we had an enolate attacking an aldehyde. However, we did this in the presence of a weaker base and a product solvent, and therefore our beta-hydroxyketone could continue to react, lose water, and form an alpha-beta unsaturated ketone. So these are the four main carbonyl chemistry, chemical reactions that we've learned at this point in the course.